Hey guys, in the previous video we were looking at translating graphs of cubics and quadratics. We also introduced the two different types of translations in X and translations in Y. So, if you want the basics, go back to that video. In this, we are looking at sketching translated reciprocal functions. So, first of all, we need to remember that the general reciprocal function looks like this. So this is a sketch of y equals k over x, where k is greater than 0, so it's positive. Now what's going on here is the x and y axes are both what we call asymptotes. Now an asymptote is a straight line that curves can tend to, they can approach it, they can get closer and closer and closer, they can get infinitely close to it, but they can never ever touch it. So, again, we've covered this in the reciprocal graphs video, so if you want this in more detail, go back, check that out. So what's going to be happening in these, as we translate reciprocal graphs, our asymptotes are going to go walkabout, and then our graph is 2 to correspond with that. So, let's get cracking. Okay, so first up, we're going to have a look at y equals 1 over x plus 3. So, let's first of all think about what sort of translation this is. This is y equals f of x plus 3. So this is a translation vertically up by 3. So what's going to happen here then? We're still going to have an asymptote on the y-axis. So we're still going to have that guy. That's not changing at all. But what is going to change is the horizontal asymptote. So the horizontal asymptote is now going to go up by 3 places. So the horizontal asymptote is going to be something like that. So let me just put the dashes in there to show that they are asymptotes. Okay, so the horizontal asymptote now has an equation y equals 3. The vertical asymptote is still x equals 0. So our graph is going to look something like that. Now there's something different here as well. We can also find the coordinates of this point where the reciprocal crosses the x-axis. Remember, on the x-axis, y is equal to 0. So to find this point, we set 1 over x plus 3 equal to 0. So if we subtract 3, we get 1 over x is minus 3. If you multiply by x, 1 equals minus 3x. And then if we divide by minus 3, we get minus 1/3 is equal to x. So this point here, where the reciprocal crosses the x-axis, is minus 1/3 0. So that is our first translated reciprocal graph. Good times. Okay, so for our second example, here we have y equals 5 over x minus 1. So, if we said here f of x was 5 over x, which is just going to look pretty much exactly the same as 1 over x. The number on top really bears no importance. The shape of the graph is going to look pretty much identical. Then 5 over x minus 1 is f of x minus 1. So, by our knowledge from the previous video, we know this is a shift to the right by 1 place. So, now we just think about where our asymptotes live. So, this time, our horizontal one doesn't change. So that is still along the x-axis, like that. So something like that. But what's happened this time, our vertical asymptote has been translated 1 place to the right. So we can put it somewhere like that. So again, let me dash those to show that they are asymptotes. Okay, so there's our asymptote situation. So our graph is just going to look like that. Okay, so we need to write the equations of our asymptotes on really. So this one is y equals 0, and our vertical one is x equals 1. So I want to think of another word there. I want to talk about another way of thinking about why that vertical asymptote is there. Remember, asymptotes come as a result of trying to divide by 0. So we have a problem here then when x minus 1 is equal to 0. So if we set x minus 1 equal to 0, solve for x, we get x equals 1. So whereas with the standard reciprocal graph, k over x, you get a problem when x is equal to 0, because you're then trying to divide by 0. Here, if x was 0, we'd have 5 divided by minus 1, which is no problem. But if we add 5 over 1 minus 1, we've then got a problem, because 1 minus 1 is 0. So that's why the asymptote shifts. Now, just like with the previous one, we can find this point where the reciprocal crosses the y-axis. So, remember, on the y-axis, x is equal to 0. So, we would get y is equal to 5 over 0 minus 1, which is minus 5. So the y-intercept here is 0 minus 5. So there's our second reciprocal translation. Good times. Okay, number 3. So let's say we got y equals 2 minus 3 over x. So if we said that f of x was minus 2 over x, then, sorry, minus 3 over x, then 2 minus 3 over x is f of x plus 2. So, what's happening here? Well, we've got a negative reciprocal graph, and it's then being translated upwards by 2 units. So this time our vertical asymptote doesn't change, so that's still going to be the y-axis. Seem to struggle drawing vertical and horizontal lines. Okay, so there's our vertical asymptote, but our horizontal one is translated upwards by 2. So that's going to be somewhere up here, like that. Okay, now actually, it's going to move that down a bit, because we have a negative reciprocal graph. So when our reciprocal part is negative, our graph lives up in the top left and down in the bottom right. So this guy is going to look like that. Okay, so as our graph, the equations of our asymptotes are y equals 2 and x equals 0. Now again, we can find the point here where the graph crosses the x-axis. So on the x-axis, y is equal to 0, so we set 2 minus 3 over x equal to 0. Now we could multiply through by x and we would get 2x minus 3 equals 0. Subtract the 3 and divide by 2, x is 3 over 2, 3 halves. So that is the x coordinate of this point, 3 halves, 0. So there's our third one, translated and sketched. Good times. Okay, now we're going to go for a double whammy translation. So we're going to have an x translation and a y translation. So we got y equals 1 over x minus 2 minus 5. So if f of x is 1 over x, 1 over x minus 2 minus 5 is f of x minus 2 minus 5, like that. So our asymptotes are going to move horizontally and vertically. Okay, so the f of x minus 2 part is going to move the vertical asymptote 2 places to the right. So that's going to be somewhere around here. And then the minus 5 part on the end moves the horizontal asymptote down by 5 places. So that's going to be somewhere like that. So the equations of our asymptotes here are y equals minus 5 and x equals 2. So our graph is going to look something like this. Okay, so that's what our graph's going to look like. Now with this one, we're hitting the axes at 2 places. So we can find both of these. So first of all, let's look at finding this guy. So this guy is on the x-axis, so that happens when y is equal to 0. So if we set 1 over x minus 2 minus 5 equal to 0, 1 over x minus 2 is equal to 5. We could then flip both sides of this, so that we would get x minus 2 equals 1/5. And then if we add 2, x is 2 and 1/5, or 11/5. So we can say the x coordinate then at this point is 11/5, and the y coordinate is 0. So that takes care of that guy. Now we can also find where we hit the y-axis. So remember, on the y-axis, x is equal to 0. So we're finding this point. So we can say the x coordinate is 0, we know that. Now we need to put x equals 0 into 1 over x minus 2 minus 5. So when x is 0, we get y is minus 1/2 minus 5, which is minus 5/2, which is minus 11/2. So our y coordinate is minus 11/2. Okay, so there's our sketch. Okay guys, that's it for this video. Hopefully you found it useful. If you want any more examples, let me know down below in the comments.